Bismillahirrahmanirrahim. Students, in this lesson I will discuss about ecological pyramids. In 1927, Charles Elton, an English ecologist, developed the concept of ecological pyramids. He noted that the animals present at the beginning of food chain are more in number, while the animals present at the end of food chain are less in number. So ecological pyramid can be defined as a graphical representation designed to show the biomass or productivity at each trophic level in a particular ecosystem. It may be defined as a representation of the number of individuals or amount of biomass or energy present in various trophic levels of a food chain. Ecological pyramids are of three types: pyramids of numbers, pyramids of biomass, pyramids of productivity or energy. Pyramids of numbers. Basic pyramid is pyramid of numbers. It represents the number of organisms at each trophic level. It can display different patterns depending on the type of ecosystem. It is the graphic representation of the number of individuals per unit area at various trophic levels. Usually producers are present in large number, primary consumers are in lesser number, secondary consumers are less, and so on. So the producers are of smallest size but maximum in number, while the tertiary consumers are larger in size but lesser in number. Pyramid of biomass. It is a graphical representation to show the relative amounts of biomass at each trophic level. In this, organisms are collected from each feeding level, dried, and then weighed. This dry weight represents the amount of organic matter of the organisms, and it's the graphic representation of biomass present per unit area at different trophic levels. Biomass. It is defined as organic matter, especially plant matter, that can be converted to fuel and is regarded as a potential energy source. So here is a pyramid of numbers in an ecosystem. Clover leaves are producers, snails are primary consumers, sparrows are secondary consumers, and hawk is tertiary consumer. Second figure is about pyramid of biomass in an ecosystem. Biogeochemical cycles. We know that environment is the source of materials for all living organisms. Environment provides bioelements which are used by organisms for their bodies and metabolism. The materials are continuously recycled between organisms and environment. Biogeochemical cycles are the cyclic pathways through which materials move from environment to organisms and back to the environment. Carbon atom is the principal building block of many kinds of biomolecules. Carbon is found as graphite and diamond in nature. It also occurs as carbon dioxide in atmosphere. Major sources of carbon for the living world is carbon dioxide present in atmosphere and water. Fossil fuels like peat, coal, natural gas, and petroleum also contain carbon. Carbonates of Earth's crust also give rise to carbon dioxide. Carbon cycle is perfect cycle in the sense that carbon is returned to atmosphere as soon as it is removed. Since such movement of elements and inorganic compounds is essential for maintenance of life, they are called nutrient cycles. The major process that brings carbon from atmosphere or water into living world is through photosynthesis. Producers take in carbon dioxide from atmosphere and convert it into organic compounds. In this way, carbon becomes a part of body of producers. The carbon enters food chains and it is passed into herbivores, carnivores and decomposers. Carbon dioxide is released back to the environment by respiration of producers and consumers. It is also released by the decomposition of organic matter and dead bodies by decomposers. Burning of food and fossil fuels also adds large amount of carbon dioxide into atmosphere. The balance of carbon cycle may be upset by human activities such as deforestation and excessive burning of fossil fuels. As a result, the amount of carbon dioxide in atmosphere is increasing, causing the great loss and effect and also global warming. Next is nitrogen cycle. Nitrogen is the important component of many biomolecules like proteins and nucleic acids, DNA and RNA. Atmosphere is the reservoir of free gaseous nitrogen. Living organisms cannot pick up this gaseous nitrogen directly from atmosphere except nitrogen fixing bacteria. It has to be converted into nitrates to be utilized by plants. Nitrogen cycling involves several stages. First is formation of nitrates. Second is assimilation. Third is denitrification. Conversion of nitrogen gas into nitrate is called nitrogen fixation. It occurs in the following ways. First step is thunderstorms and lightning convert atmospheric gaseous nitrogen to oxides of nitrogen. These oxides dissolve in water and form nitrous acid and nitric acid. The acids in turn combine with other salts to produce nitrates. It is called atmospheric nitrogen fixation. Some bacteria also have the ability to transform gaseous nitrogen into nitrates. It is called biological nitrogen fixation. Some of these nitrogen fixing bacteria live as symbionts and many are free living. Nitrogen fixation is also done in industries, and in industries nitrogen fixation process hydrogen is combined with atmospheric nitrogen under high pressure and temperature. It produces ammonia, which is further converted into ammonium nitrate, as you can watch in industrial nitrogen fixation process here. The next is ammonification and nitrification. Ammonification is the breakdown of proteins of dead organisms and nitrogenous wastes such as urea and uric acid to ammonia. It is done by ammonifying bacteria. After the formation of ammonia, it is converted into nitrites and nitrates. It is also called nitrification and it is done by nitrifying bacteria. First, ammonia is converted into nitrites by bacteria, which is nitrosomonas. The nitrites are then converted into nitrates by other bacteria, which is nitrobacter. So here are the steps of nitrification. First, in nitrogen fixation, nitrogen is converted to ammonia. In ammonification, conversion of organic matter into ammonium. In nitrification, conversion of ammonium to nitrates to form most often taken up by plants. Now I will discuss about assimilation. The nitrates formed by the above processes are absorbed by plants and are utilized for making proteins. Animals take nitrogenous compounds from plants. The utilization of nitrates by organisms is called assimilation. Last step is denitrification. D means breakdown. So it is the biological process in which nitrates and nitrites are reduced to nitrogen gas by denitrifying bacteria. By this process, nitrogen is returned to atmosphere. Excessive denitrification reduces soil fertility and is stimulated by water logging, lack of aeration, and accumulation of organic matter in the soil. So I have discussed about formation of nitrates and nitrogen fixation. I have discussed about industrial nitrogen fixation, and at the end I have discussed about nitrifications, steps of nitrification. Thank you and have a nice day.